This is Unit 7, Day 1, Part 2. Okay, Example 7. Use your graphs from Example 6 to show the following. How does y equals negative x cubed compare to y equals x cubed? Be specific, including the correct transformation vocabulary and behavior. All right, well, it's a reflection over the x-axis, and we already talked about that, okay? Its end behavior reverses, okay? So it completely switches. So what do I mean by that? Normally, x cubed, as x approaches positive infinity, y also approached positive infinity, and as x approached negative infinity, y approached negative infinity. Well, that completely reverses when you put in the function y equals negative x cubed. So what does that mean? That meant, now remember, this one was for x cubed. So what does that mean? For negative x cubed, as x approaches positive infinity, y approaches negative infinity. As x approaches negative infinity, y approaches positive infinity. So that's what that means when they reverse. Okay, what happens when you have y equals 3x cubed compared to the original? We already talked about this. This is a vertical stretch by 3, which means it's getting narrower, closer to the y-axis, but your end behavior stays exactly the same. Okay, so again, here's the end behavior for x cubed. 3x cubed stays exactly the same. Example 8. Which of the following power functions have the same end behavior? Categorize them in the table below. Do this without the use of your calculator. Alright, so basically, you notice, look at, if x goes to positive infinity, y goes to positive infinity. If x goes to negative infinity, y still stays to positive infinity. Guys, that's your normal even functions. Okay? And we just learned in the previous example, it was okay that there were stretches or compressions there. Your end behavior still stayed the same as all of your evens. So I go through, and which ones have even exponents? That could be a vertical stretch or compression. It'll be y to the 5th, 5x to the 6th. It will be 1/2 x to the 4th, and that's it. There's just those two. Now you might ask, well, why didn't I do this one? Well, guys, that has a reflection. Reflections switch, so you can't have the negative sign. So this one, the first box, is only y equals 1/2 x to the 4th, and y equals 5x to the 6th. Now, so you need to memorize this end behavior right here, that they stay positive. And those are your normal even functions. Who cares about the vertical stretches and compressions? The next one says, as x goes to positive infinity, y goes to negative infinity. As x goes to negative infinity, y goes to negative infinity as well. So hopefully you memorize that and know that this is an even function, but it has a reflection over the x. So those are going to be the ones with the even powers, but there's a negative. Okay, even powers, but there's a negative. So all the ones I highlighted in green. So y equals negative x to the 4th, y equals negative 1/3 x squared, and y equals negative 2x to the 4th. The next box, the end behavior, has that of a normal odd. Okay, so if you go back and you think about what y equals x looked like, what y equals x cubed, as x approached positive infinity, y approached positive infinity. As x approached negative infinity, y approached negative infinity. Okay, so that end behavior is going to be your normal odds. So then you might say, well, what's my normal odd functions? 3x cubed, x to the 5th, x to the 7th. Anything highlighted in blue. Oops. So y equals 3x cubed, y equals x to the 5th, y equals x to the 7th. Okay? And then the last one is going to be flipped. These are your odd functions, but it has a reflection over the x. Okay, so that's all the ones that are remaining that I didn't highlight. So y equals negative x cubed and y equals negative 2x to the fifth. Okay, so if you think about their graphs, these go positive, positive. Okay, so that's positive even. This one goes negative, negative, which is a negative even function. So they're both flipped, right? These were both positive, those go both negative. Normal odd functions go positive over on the positive side, negative over on the negative, so that's a positive odd function. And then if you reverse those, it goes positive on the odd side, the negative side, but negative on the even side. Those are your negative odds. Okay, those are all possible for situations.